I'd like to take some time today and talk with you about how to integrate TMCC and/or legacy into a two-rail S-Gauge layout. It's important that you first understand the difference between command and conventional operation. Conventional operation simply means that you're controlling track power up and down, and as you increase track power, the train runs faster. As you decrease track power, the train runs slower. In an instance like that, we call that controlling the track. Command control is something totally different. What we do in command control is we apply 18 volts AC power fixed to the track, and we broadcast a signal through one or two rails, and it's an airborne signal that tells the train what to do. So instead of controlling the track in a command environment, we're controlling the trains individually. In a command environment, you can have up to as many as 99 locomotives on one track at one time and control each and every one of them independently. Let's talk about how all of this works. We'll cover conventional in just a few minutes, but let's talk about command. We have two systems to choose from at Lionel. We have the older, obsolete system, which is known as TMCC in the marketplace, or Trainmaster Command Control. TMCC was the command system that Lionel released in 1996 and had been the standard of the industry up until about the release of the new legacy system in 2007. The new system is called Legacy. Legacy is the standard that all of our new S-Gauge models are built to. So starting with the big boy, the Challengers, the U30 and U33Cs, and the soon-to-be released Y3 2882s are all built to legacy standards. What's the difference? The difference is pretty simple. With TMCC, you were limited to an 8-bit command signal going to the locomotive, which gave you quite a bit of functionality. 32 speed steps, horn, bell, volume up, volume down, start up, shut down, etc. With the introduction of Legacy, what we've done is we've added an extra bit of data in the signal transmission. So with Legacy, we now have the ability to send either 8-bit commands to locomotives that are only equipped with TMCC. Example of this would be the American Flyer Pacifics and the American Flyer Mikados that are equipped with TMCC. The Legacy system will also send 9-bit signals, which are signals designed to broadcast to legacy-equipped locomotives. Everything that you had with TMCC, you now have about double with Legacy. Instead of 32 speed steps with TMCC, legacy locomotives feature either 100 or 200 speed steps. With TMCC, you had just a single note horn that would blow or whistle that would blow. Now with Legacy, you have a quillable horn or whistle, and you can control all three levels of that quillable sound. There's a whole slew of other features that Legacy brings to the table. 3 levels of smoke, as opposed to only 1 level of smoke. The expanded speed steps, preset railroad speed steps, sequence control, a whole slew of products, or a whole slew of feature sets that are available in Legacy over TMCC. Now, you may ask, what's the difference operationally between these two? Aside from the 8-bit and 9-bit signal transmission, the frequency at which those commands are broadcast on the track remains the same. And that frequency is 455 kilohertz. Now, while this really isn't important, it is important to understand that we have really 3 frequencies that we work with within Lionel. The first one being 455 kilohertz. This is the signal that is broadcast from the base out to the rail and then through the rail into the air, and it's received by an antenna inside the locomotive, and the locomotive performs whatever commands you send to it. The other 2 frequencies that we have is TMCC. This wireless remote was referred to as a cab 1. It would broadcast to the TMCC1 base at 27 megahertz. The legacy system, this wireless handheld, broadcasts to the base at 2.4 gigahertz, which simply means a cab 1 remote will not talk to a legacy base, just the same as a legacy remote will not talk to a TMCC 1 base. The 455 kilohertz remains the same, so that we're able to use the same broadcast frequency for TMCC locomotives as we use for legacy locomotives. So once again, in a command environment, using either TMCC or legacy, we apply a fixed 18 volts AC to the track. The 455 kilohertz command signal is present on the rails or in the air, propagated through the rails. It's received by the antenna in the locomotive, and the locomotive awaits a command from the remote to do something. Be it start up, move, blow the whistle, ring the bell, fire the coupler, etc. Now, this covers command operation. It is important to note that the performance of your legacy and your TMCC locomotives are also affected by power. We've made a separate tutorial video called Transformer Sine Waves, and it basically talks about the primary differences between smooth sine wave transformers and chopped sine wave transformers. The differences, as shown in the video, basically pertain to the performance of your smoke unit and the operation of your coil couplers. A lot of operators out there have older American Flyer or even Lionel post-war power, and all of those transformers are smooth sine wave. I encourage you to watch the sine wave video so that you can see how those transformers versus the newer, more modern chopped sine wave transformers affect the performance of your locomotive on the track. Now let's talk about the signal propagation itself. That 455 kilohertz signal in a 3-rail environment is broadcast through both outside rails. In a 3-rail environment, the center rail is hot, and the 2 outside rails are commonly referred to as ground. Both outside rails are tied together, and they come down and they tie to the base. Again, the base can be a TMCC 1 base, or it can be a legacy base. Nevertheless, the signal is still 455 kilohertz. In a 2-rail environment, what happens is we're only broadcasting the signal from 1 rail. Because if we connect this terminal to both rails, it's a dead short. So, we have ground and we have hot on our 2 rails, AC power, fixed at 18 volts. Some layouts may experience a problem with the signal strength, meaning you're running your train and suddenly one of 3 things will occur. The first thing that can occur is that the locomotive just stops dead and doesn't move, doesn't respond to commands. The second thing that can happen is that the headlight stops dead and it flickers violently, telling you that, hey, I'm not picking up the command signal here, do something. And the third thing the train can do is drop into a conventional environment where it no longer sees the radio signal, it looks down at track power, it says, I see 18 volts, and it takes off at 18 volts out of control, and you're helpless to do anything from your remote. If you have a scenario like that on your railroad, you could really have one of 2 different problems. Your first problem could simply be you've got too much signal, and we have a product video out there called TMCC Legacy Signal Basics. I would encourage you to watch that video to understand how ground planes can solve your over signal issues on your railroad. But let's assume for a minute your problem is you don't have enough signal. That can be easily fixed. And the way we do that is we use a capacitor. That capacitor is a 0.1 microfarad 50 volt ceramic capacitor. Ceramic is very important in this instance. What we can do is we can use a method called capacitive coupling. And we can take this 455 signal that's broadcasting through one rail and allow that signal to pass through a capacitor so that it broadcasts out of both rails. This capacitor will allow the command signal to pass through it so that you've got two rails propagating the signal, but it will not allow power to pass through the capacitor. So we can have AC hot powering one rail, AC ground powering the other rail, and our signal is all that will pass through our capacitor so that we're able to propagate a signal out of both rails without creating a short circuit. But once again, go back and check the TMCC Legacy Signal Basics video before you start adding capacitors on your railroad. Because your problem could be that you've got too much signal. Adding more signal is certainly going to make it worse before it makes it better. Now, this covers command operation. Let's talk about conventional operation. On your S-Gauge railroad, you will now have one of two different wireless remotes, either a cab 1 or a legacy remote. Instead of just being stuck operating trains as opposed to operating track, you can really control your entire empire using that wireless handheld device, cab 1 or legacy remote. The way you do that is it requires some stationary devices that go between your accessories, your switches, and your track and their transformer. Let's talk about conventional operation. You want the ability to control track power up and down using a wireless remote. So if you're using TMCC 1, you have really 4 choices. Your first choice is called a Power Master. Your second choice is a TPC, either a 300 or a 400. We have 2 models, silver and black. Black is 300, silver is 400. We'll get into that in a minute. Third option is a ZWC, and the fourth option is a ZWL. Fortunately, on the Lionel website, we have product videos covering all 4 of these devices. The Power Master basically gives you the ability to have up to 7.5 or 10 amps of power, circuit protected power, to the track. The TPC gives you the ability to have 15 or 20 amps of circuit protected power to the track. The ZWC, providing you purchase you purchase 2 additional 180 watt powerhouses, gives you the ability to have 10 amps per track, and there's 4 tracks are controlled by a ZWC. And the ZWL will give you the ability to have 36 amps spread across 4 tracks. And this is a self-contained unit, whereas the ZWC has external power supplies. Now, any one of these devices will allow you to take your wireless remote and control your track power up and down, as well as direction, so that you're able to control the track power to operate conventional locomotives. If any one of these devices are used, you can take and set the track power all the way at 18 volts, use your command signal, and then run your trains in a command environment. The only thing that changes here slightly is when we enter into legacy. When we use legacy, the only variable here is the TPC still applies, the ZWC and the ZWL are still valid products. But if you've chosen to use a Power Master, when you use a legacy system, you have to add on a device called a Power Master Bridge. And basically what the Power Master Bridge does for you is it converts the frequency in which the base communicates with the PowerMaster itself. There's a separate product video on why and how to use the PowerMaster bridge and when it's necessary. Encourage you to watch those. We can also control accessories and switches using our wireless handheld remote. The two devices that we have in the marketplace for doing this are called an ASC and an SC2. Both devices perform very similar features or functions, but they have different features about them. Again, product videos on ASCs and SC2s on the Lionel site that can help you understand specifically how to wire your switches and your accessories so that you're able to control them from the wireless handhelds. That basically sums up adding legacy or TMCC to a two-rail layout. A couple things you want to go back and review. The first being the sine wave video so that you can see how it affects the performance of your locomotives. The second being the product videos for the PowerMaster bridge, PowerMaster, both TPCs, the ZWC and the ZWL. Also the product videos on the ASC and the SC2 and how they pertain to switches and accessories. Adding legacy or TMCC to your two-rail layout is really pretty simple at the end of the day. The only difference is you don't have a third rail. But with what we've shown you here today, you have the ability to propagate the signal in the same manner in which it's propagated in three-rail. You understand that legacy-equipped locomotives have the ability to communicate on a 9-bit level, and TMCC locomotives have the ability to only communicate on an 8-bit level. We also have several videos on the site pertaining to legacy. How to use it, how to access all of the features, how to set it up, etc., etc., etc. Encourage you to watch those videos. After you've watched the videos, if you have any questions at all about adding legacy to your two-rail layout, specifically two-rail S-Gauge layout, please feel free to email us in customer service at talktous@lionel.com. We'll be happy to answer any questions you may have and help you get the most out of either the TMCC or the legacy system, and especially your legacy-equipped S-Gauge locomotives.